Okay. 10-6, radical equations. Now we're putting in an equal sign, okay? There's a specific way on how you solve these equations. Number one, I gotta isolate the radical on one side. Take the radical, get everything away from it. Kind of like isolating the x in algebra, right? This is still algebra. You gotta isolate that radical sign. Two, you're gonna raise both sides to the degree that's matching the root of the radical. So if it's a square root, you square it. If it's a cube root, you cube it, okay? But you have to do it to both sides. It's still that idea, if I'm solving for x, I gotta keep things balanced, okay? So I'm gonna solve it, and here's the big thing too. You gotta check the results. Some of these results or answers may be what they call extraneous solutions. In other words, they don't work, okay? So let's take a look. Okay, now in this example, you can see that I have the square root of 2x plus 3 is equal to 5. I have this square root that's isolated. There's nothing in front or behind. It's all good. Great. So I go to my step 2. I have to match. This is the square root. So I do the opposite of square root, which is square, but I do it to both sides. I square this, and I square this. Notice, keep it balanced. The square root and the square eliminate each other. Well, that's what we wanted. We wanted it to eliminate, to get rid of that radical sign. I did. 5 squared, which is 25. Now all I'm going to do is solve this just like I would any normal algebra problem. So I'm going to subtract 3. So I get 2x is equal to 22. Divide by 2. X is equal to 11. Well, you're saying, great. Well, that's pretty simple. But here's the thing. I have to check it. I have to check it in this original to see if it works. So now I'm going to go check the result. So I have this. I had the square root of 2x plus 3 is equal to 5. Plug 11 in for x. The square root of 2 times 11 plus 3, does that equal 5? Well, 2 times 11, which is 22. 22 plus 3 is 25. Does the square root of 25 equal 5? Yes. That checks. In other words, this is a solution. That works. That's good. Perfect. Next. Now here is one. I've got my radical sign, but I also have this number. Get it to the other side, so I'm going to subtract 6. So I have this. The square root of x minus 3 is equal to negative 1. Now, I've isolated the radical, and now all I have to do is to square it. If it's a cube root, you cube it. But this is square root. That eliminates, so I'm just left with x minus 3 is equal to, I square negative 1, which is 1. Super. Add 3. X is equal to 4. And now check the solution. So my original problem was x minus 3 plus 6, does that equal 5? That's the question. So plug it in. I have 4 minus 3 plus 6 is equal to 5. 4 minus 3 is the square root of 1 plus 6. Does that equal 5? Well, the square root of 1, which is 1, 1 plus 6, does that equal 5? Well, the answer is 7 does not equal 5. No solution. That's why it's imperative for you to actually check the results. Okay? Moving along. Now we start to get a little bit more, the difficulty level is now increased. Okay, notice I have this x over here. I'm going to move it to the other side. I got the square root of 26 minus 11x is equal to, if I subtract x, I get 4 minus x. Okay, cool. Isolated the radical. Perfect. Now, square both sides. Okay, cool. So I got to square this, and I got to square this. Well, that eliminates, so I'm just left with 26 minus 11x. Easy part. 4 minus x. Easy. Is 4 minus x. Write it twice. Write it twice. If you have a squared, that means that that's twice. Guess what? FOIL it. So I have this 26 minus 11x is equal to 16 minus 4x, the inside, which is minus 4x, and the last, which is plus x squared. We've got a lot of combining like terms. 26 minus 11x is equal to 16 combined minus 8x plus x squared. Now guess what we have to do? You got to think back to the last chapter. Once I have this, I got to get it all equal to 0. So I got to move everything over and get it equal to 0. And it's got to start with that x squared. So I'm going to add 11x over here. And I'm going to subtract 26 over here. So now I got 0. I'm just going to rearrange the order. X squared goes first. This is plus 3x, and that's minus 10. 16 minus 26 is minus 10, and that's my 3x. I just reverse the order. Now what I have to do is to, all together now, factor. Great. So I factor this. X plus 5, x minus 2. Now I factored it. I got to set each one of these things equal to 0. I got to find my solutions. So x plus 5 equals 0. Subtract 5. X equals negative 5. X minus 2 equals 0. Add 2. X equals 2. So now I have 2. Notice, if you have x squared, sometimes you're going to end up with 2 solutions. Possible solutions. I have this, negative 5 and 2. I have to try them. I got to try them up here. So I have this, x plus the square root of 26 minus 11x is equal to 4. Well, let's plug in negative 5. I'm going to plug in negative 5. Negative 5 plus the square root of 26 minus 11 times negative 5. Does that equal 4? Well, I got to do some work here. Minus 5 is equal to, that's a plus, 26, and this is plus 55. Does that equal 4? So this is minus 5 plus the square root. When I add these two things together, I get 81. Does that equal 4? Well, the square root of 81 is 9. So negative 5 plus 9, does that equal 4? Well, the answer is yes. Great. This is a solution. Yes. Now let's find out if the other one is a solution. I'm going to erase this. And let's find out if this other one is the solution as well, because there could be no solutions called extraneous. There could be one solution, or there could be two. So let's try 2. So I have 2 plus the square root of 26 minus 11 times 2. Does that equal 4? Well, let's work it out. 2 plus the square root of 26 minus 22, does that equal 4? 2 plus the square root of 4 equals 4. Does it? 2 plus 2 equals 4. 4 equals 4. And that works. So I have 2 solutions, which is okay. You can have 2 solutions. Great. Okay, next. Whew. This one's going to take a little bit of work. Now I've got a square root on each side. So what I'm going to do is I'm going to move one of the square roots to the other side to isolate one of the square roots. So I'm just going to add the square root of x plus 4 to each side. So I have this. The square root of 3x plus 1 is equal to the square root of x plus 4 plus 1. If you have two square roots on the same side, put one on each side, okay? Remember the next step, isolated, kinda, okay? Isolate the left, square both sides. So I have, well, this is easy, 3x plus 1. That's the easy one. I gotta write this twice. Now this is going to be interesting, because now I gotta FOIL this. Well, when I multiply these two together, multiplying a square root and a square root of the same thing, the square root sign disappears. Okay, cool. Great. Now let's multiply these. Well, that's just plus the square root of x plus 4. And the inside, well, that's just plus the square root of x plus 4. And the last, which is 1. Still got work to do. 3x plus 1 is equal to, now I'm going to start to combine some like terms. I've got x, and I've got this plus 5 plus 2, the square root of x plus 4. Combining some more like terms with this. X plus 7